Okay, so we're going to be doing extraction of metals today. The crust is mostly made of compounds, but it also contains some elements such as copper, silver, mercury, platinum, gold. They are native or uncombined because they're very unreactive. Okay, so in this circle, in this pie chart, you can see the different compositions of the Earth's crust and how it's made up of different elements. Okay, so some of these metals are very precious because they're scarce, expensive, and they are often kept as a store of wealth. The car industry uses a lot of metal. Cars are mainly made of steel plus over 5% of aluminium. So but then the steel is coated with zinc and the bumpers with nickel and chromium. The electrics of the car depend on copper, the battery uses lead, and modern exhaust contains platinum and rhodium as catalysts. So we need these metals, but how to obtain them from the Earth's crust? There are different types of mixtures that are present in the Earth's crust, such as bauxite, which is mainly aluminium oxide. Gold occurs naturally as pure gold. There are chunks of rock salt, such as sodium chloride. So basically, we obtain them. Now, there are different ways of extraction of these metals, and we are going to be discussing them today. Okay, usually we use reduction. If you can define reduction is two things. One being loss of oxygen. So for example, if I have iron oxide, Fe2O3, this going to Fe, this is reduction. Number two, gain of electrons. Okay, so if I have Fe3 plus and I gain 3 electrons, this is going to be either way the metal is reduced. Now there are different methods of extracting metals. Let's write our heading: extracting metals. Okay, number one is for unreactive metals. Examples include silver, gold. So Ag, gold, Au, they occur in the ores as element. All you do is do mechanical separation, physical separation of them, and that's it. Okay, just like you're separating the metal from sand and other impurities, it's like removing stones from the soil. It does not involve any sort of chemical reaction. Okay, so this is mechanical separation for such metals. Then second method is for the ores of the other metals, the ones that are in compounds. Metals as compounds. Okay, metals as compounds. Here what we have to do is that we have a metal compound, we have to reduce it. We conduct reduction on it for it to produce a metal. Okay, now for the very reactive metals, we use electrolysis on them. So the compounds of more reactive metals are very stable and they need electrolysis to reduce them. This is a very powerful method, but it costs a lot because it uses a lot of electricity. And the fourth method is for compounds of less reactive metals. Okay, and we use a suitable reducing agent for them to be reduced. Now let's revise the reactivity series. Okay, we have potassium, we have sodium, we have calcium, we have magnesium, we have aluminum. These are all the metals here. Then comes carbon, then comes zinc, iron, lead, then comes the most unreactive one, which is silver and gold. Now for the first method, for these ones, we use electrolysis. So till here, till aluminum, we use the method of electrolysis. Then from here, from zinc to lead, we heat with a reducing agent. Usually it's carbon or carbon monoxide. And then lastly, these both, they occur naturally, so no chemical reaction needed. Okay, the reactivity increases like this. Let's write it here. Reactivity increases, and then same way, ores are more difficult to decompose as you go on the top. Ores are more difficult to decompose. Okay, now we use carbon as a reducing agent usually. Let's do some examples. There are 3 examples of the ore extraction. Okay, number 1 example is the iron ore. It has mainly iron 3 oxide. You have Fe2O3. I reacted with carbon monoxide, and since in the reactivity series carbon is more reactive than iron, it can replace it. Now what's the concept of here? You have a chair and someone is sitting on that chair. Okay, wait, let's make it better. You have a big guy sitting on a chair and there is a small guy. Can the small guy kick this big guy out? No, because he's not powerful enough. But can we do it the other way around? Can this one kick this one out of the chair? Yes, it can. So it's the same thing. If something is more reactive, it can kick the less reactive one out and take its place. Okay. So iron oxide reacts with carbon monoxide and it forms iron and carbon dioxide. Let's quickly balance these. Okay, so this is one method. We are going to look this more closely in blast furnace part. Number 2 is the aluminium ore. So this is mainly aluminium oxide. Aluminium is all more reactive than carbon. So this time we would need electrolysis. So this one would need electrolysis as aluminium is more reactive than carbon, so carbon cannot kick this out. Okay, I have a compound like aluminium oxide in liquid form and I perform electrolysis on it. You're going to study electrolysis in detail. Aluminium and oxygen is going to form. Right now all you need to focus on is that what method are you going to use based on the reactivity series. Okay, lastly we're going to go for zinc blend. This is mainly zinc sulfide basically. This has some steps. Okay, so you first roast it in air and then give zinc oxide and sulfur dioxide, and then that is further reduced. So there are 2 methods. First you have zinc sulfide and you're going to react it with oxygen to form zinc oxide and sulfur dioxide. So 2, 2, 3, 2. Okay, now this zinc oxide is reduced in 2 ways. Number 1 is that I use carbon monoxide. So this is carried out in a blast furnace. Zinc oxide reacts with carbon monoxide reacts with carbon monoxide to form, what's going on, to form zinc and carbon dioxide. This is solid getting produced, and that's a gas. Okay, then the final mixture would have zinc and a little bit of impurities. Then the zinc is further separated by fractional distillation, which I'm sure you have studied in chapter 2 of IGCSE, fraction distillation. Then second method of obtaining zinc from zinc oxide is electrolysis, but this is theoretically possible, not practically, because zinc oxide has a 1975 degrees Celsius of boiling point. So it's very high to do this, and it's insoluble in water. So I can't even form it a liquid, and as you know, in electrolysis I need this to be dissolved in water. So instead what I do is dissolve in sulfuric acid, H2SO4. Okay, this is aqueous, and since reacted with zinc oxide, and since it's an acid base reaction, neutralization will happen and the solution will give me zinc sulfate, and then this is further electrolyzed. So and then I will get a reaction of zinc 2 plus 2 electrons, and that would give me zinc sulfate at the cathode. So you'd understand this if you have studied electrolysis. So this is for it now. If you have, okay, yeah, one more part. Why do we do such a hard process to obtain zinc? Zinc is used to galvanize iron, which means basically coating it to stop rusting. Why do we coat it? Because zinc is less reactive than iron, so it stops the iron from reacting. In the sacrificial protection of iron structures to make alloys such as brass or bronze, and to make batteries. So we need a lot of stuff for zinc. If you're going to continue lessons, we are going to study more about blast furnace in detail, the process of it, the reactions in it, and how do we do these. Like, we're going to study all of these in detail. Let me know if any questions.